The first method of factoring we are going to look at is common factoring. When taking a common factor, you look at the greatest common factor for each of the terms in the expression or equation that you're trying to factor. So in this example, there are 1, 2, 3 terms. So we are going to look for the greatest common factor that goes into all three. So in this question, our greatest common factor is 3x because it divides into all three terms. So to write the answer, I write 3x on the outside of the brackets, and then on the inside of the brackets should have 3 terms because I had 3 terms to start with, and I basically divide 3x into each of my terms. So I'm left with 2x squared minus x plus 3. Before you finish the question, it is always a good idea just to inspect the terms left in the brackets to make sure that there is not another common factor that you can pull out, which would mean you pulled out a common factor but not the greatest common factor. And then it is always a good idea to check your work by expanding the brackets. So here I get 6x cubed, and then I get minus 3x squared, and then I get plus 9x, which is the original question that I was asked to factor. So the question was in standard form, and the expression that when I factored is called factored form. The next method of factoring we are going to review is called the difference of squares. So here I have 2 examples I'm going to look at. And the first one is x squared minus 4. What I should always do before any other type of factoring is look for a common factor. Here I do not see a common factor, so I'm going to now choose a different method. I notice that it is a binomial because there's 2 terms, and it is separated by a negative sign, and both terms are perfect squares, meaning I can take the square root of both terms. So to write my answer, I have 2 sets of brackets. I take the square root of the first term, so the square root of x squared is x. I put that at the beginning of each bracket, and then the square root of 4 is 2, so I put that at the end of each bracket. And then in the middle of the 2 terms in each bracket, I separate the first with a plus and the second with a minus. These can be in either order as long as one has a positive and one has a negative. And again, I should just inspect my answer to make sure that I've fully factored. I don't see a common factor in either of my factors, and I don't see that I can perform another type of factoring such as difference of squares. So now I'm going to look at my next example, x to the exponent 4 minus 16. I cannot take out a common factor, and I notice it's a binomial separated by a negative sign, and both terms are perfect squares. So again, I'm going to set up the 2 brackets, take the square root of x to the 4, which is x squared, because x squared times x squared is x to the 4 because you add the exponents, and then take the square root of 16, which is 4. And again, I'm going to separate the terms with a positive and a negative. And now when I inspect, I see x squared plus 4. I cannot take out a common factor. It is a binomial with perfect squares, but I'm separated by a plus. So there's nothing I can do with this factor. But then when I look at the second factor, they're both perfect squares, and it's separated with a negative. So that means I can keep factoring this second term. So now I'm going to factor the second bracket, which I've highlighted in yellow, and I get x plus 2, x minus 2. And again, you can expand all these terms to get back x to the 4 minus 16.